Welcome to HB Tuner's GM Gen 4 Training Part 46. This training module, we're going to be doing a demonstration of calibrating both the mass airflow and speed density at the exact same time. This is going to be speeding up our calibration process greatly because we don't have to put the engine control module into either airflow mode. We can actually do everything at one time. This requires heavily on us having our VCM scanner set up. We went over that in the last tutorial, so we're going to jump into this tutorial and look at the process from start to finish and rely heavily on all of the filtration and all of the VCM scanner histograms that we've created and talked about in our last tutorial. Without further wait, let's jump in so we can check this out. Okay, so let's get started. We're going to be taking a look at dialing in our mass airflow and speed density at the same time. This will save us a tremendous amount of calibration time and effort. It's going to be speeding up everything that we're going to do, and it's going to make our transient throttle more accurate. And if you have an automatic transmission, it'll make your torque calculations more accurate, therefore making your transmission shifting a bit crisper, a bit more accurate, and tracking more of what the OEM GM programming logic was trying to go after in terms of the torque referencing and a lot of the torque-based tables for automatic trans control. So these are all good things, and this calibration method is what I've been exclusively using for about the last year. So let's go in and take a look at how we're going to accomplish this. This particular calibration file I'm starting off with is a 2012 Yukon Denali calibration file. That's our test vehicle from our Gen 4 course. This vehicle has an engine cold air intake, Cook's long tube headers, and a Corsa catback exhaust. Very basic modifications, but this is a great vehicle for demonstrating how we can dial in both airflow methods at the same time. If you have a cam or your force induction, calibration method is going to be the exact same as what we're outlining here. So nothing really changes. It's just going to keep things simple, at least just to show the concept here of how everything's going to work. Let's jump into the calibration file. I want to talk about a couple things that I've updated and changed in this calibration file, so we have a point of reference moving into firing up the engine and then capturing our data logs so we know exactly what's going on. Let me jump into the calibration file here. I'm going to go into the engine tab. If we go from general into airflow, under the general, we have a mass airflow calibration curve. We're going to dial this in. I've returned this back to stock. Previously, I dialed this in and tuned it in our earlier training modules from our Gen 4 course. I returned this back to stock so I can show that process from start to finish of getting things sorted out with the mass airflow curve. Now I also have went in and made sure that I put any of my VE coefficients back to stock values as well. So this vehicle is going to be we're going to be doing a virtual VE based tune on this, as well as dialing in the mass airflow at the same time. This particular calibration or operating strategy does have a 2-bar operating system. I could have an enhanced operating system, allowing me to get rid of the virtual VE and just focus on the 3 VE tables, just as we would have in a Gen 3 GM. I'm not going to do that. I don't want to do a right and tire and waste the time showing that. Dialing in either speed density option, virtual VE or dialing in the 2-bar operating system, is the exact same thing. It's just looking at different point of reference in your histogram list. So we have one set for virtual volumetric efficiency. We also have another histogram channels list for the 2-bar operating system. So depending on which mode you're operating in for speed density, which you've assigned your calibration file to, that's the one that you're going to be working with and transferring your data from your histogram back into dialing in your volumetric efficiency table. So I'm choosing not to do the 2-bar enhanced operating system and just stick to the virtual VE that we've covered earlier in our previous training modules. So we should understand the virtual VE, we should understand the 2-bar operating system, we should understand the mass airflow, how all that fits together. Now we're putting essentially all the pieces of the puzzle together and dialing is in at the same time. So I've returned those back to stock, which is important to note. Okay, so the other things I want to talk about here under engine, if we jump up into fuel, I have not went in, if I go into Decel fuel cutoff, I have not disabled the Decel fuel cutoff. I'm using the filters in our filter channels list to make sure that we're not going in and accounting for any overrun fueling conditions in our histogram plotting of our data. So we can use the filters to strip away the overrun conditions. We don't have to go in and turn off the Decel fuel cut. One thing I am going to do real quick here, if I go into the oxygen sensors, is I am going to disable the long-term fuel trims. We only want to work with short-term fuel trims. The long-term fuel trims can skew our airflow calibration process. So if previously in other training modules, I was doing short-term, long-term, and I was averaging them together, plotting that data into the histogram. I found that there are some oddities in the long-term fuel trims over time. Now, they can stay there in terms of some of the stock programming, how it works in the long-term fuel trims. Those can stay there once you're done with this calibration process. You can turn the long-term fuel trims on and let them trim, but when we're doing our airflow process here, dialing in the MAF, dialing in speed density, we don't want to absorb any errors from the long-term trims into any of our airflow modeling. So we want to make sure we're turning the long-term off. Let me go here and set my long-term field trims. I'm going to set this minimum ECT to something like 280. I'm going to set my limits here to something like 1.0 for both of these, so it doesn't have any authority to do anything. The baro here, I'm going to set all to 120, which is above atmospheric pressure. That way it turns that off. We shouldn't really have to do much else here. There's idle cell thresholds. We can see enable, disable. I'm going to just set these to 0. Just going to zero out a couple different things here. This should be enough to be able to turn off that long-term fuel trim. So I'm going to go here and do file and save as. So I am disabling long-term fuel trim. Another thing I'm going to make sure is that I have my flex fuel tuning feature disabled. In this particular case, I want to dial my airflow model in without having... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.